Today we discovered the properties of a rhombus. So in your properties chart, we have the rhombus right here. I think in your chart the square is here and the rhombus is to the right of it, but I reorganized the table so that way they're in the order that we do them. So that's just why mine is different from yours. But in the rhombus, we have opposite sides are parallel. So AB is parallel to DC and AD is parallel to CB. So that means they have the same slope. So we use the slope formula 2 times to prove that AB is parallel to DC and that AD is parallel to BC. The next property is that opposite sides are congruent. So if this figure was in the coordinate plane, we would use the distance formula to prove that the length of this side is equal to the length of all of the other sides. We also have all sides being congruent. So not only are opposite sides congruent, but all sides are also congruent. And the way that you can prove that all sides are congruent without having to do the distance formula 4 times is that you can just prove the distance of 2 consecutive sides. So let's say you just proved the distance of this is congruent to the distance of this side. They are consecutive because they are next to each other. Then you have proved that all sides are congruent. It was like when we were proving that a rectangle has 90-degree angles. All we had to prove were that 2 intersecting sides created 90 degrees. That's kind of the same idea. We just have to prove 2 sides are congruent, and we have proven congruency. Opposite angles are congruent, so this angle is congruent to this angle. This angle is congruent to this angle. A rhombus does not have 4 right angles. Just look at the picture itself. Do either of these angles look like a right angle? No. So we put a no for that one. Diagonals are congruent. No, this one is shorter than this one. You can tell just by looking at the figure. However, diagonals do bisect each other. So this piece is congruent to this piece, and this piece is congruent to this piece, but they are not the same measure. Diagonals are perpendicular in a rhombus, so they meet at 90 degrees. And this is interesting because this is a right triangle now, we can use special triangles, Pythagorean theorem, or trig in order to find missing side length. So you can use all your geometry tools just because the diagonals are perpendicular. The diagonals bisect the vertices, so this part is equal to this part of the angle. Same with all the other angles. And only one set of opposite sides is parallel? No. So if we look at this here, all we have to prove is 2 things in order to prove we have a rhombus. So remember with the rectangle, we had to prove that opposite sides were parallel and it had 4 right angles. With the parallelogram, all we had to prove was that opposite sides were parallel. But now with the rhombus, we only have to prove that opposite sides are parallel and that it has all sides congruent. So remember how we say the parallelogram is the cheapest figure? It has the least amount of properties that you have to prove. It only has 1 property, so it's on the first floor. Then above it, we have the rhombus and the rectangle, which are a little bit more expensive. You have to prove 2 properties, so we say they're on the 2nd floor. And then up here we have the square, which is the best figure. And for that, it's on the 3rd floor, and you have to prove 3 properties. Another way to look at this relationship between quadrilaterals is that think of the parallelogram as like the overarching shape, right? So a parallelogram could be a rectangle or a rhombus. Sorry, I didn't label this. And then a square could be a type of rhombus. So, therefore, we can say that a parallelogram, all squares are parallelograms, but we can't say that all parallelograms are squares. It's kind of like the 9th and 10th grade analogy that Miss G was going over in class. So let's do an example. Here it says in rhombus LMPQ, so LMPQ, the measure of angle QLM, so this angle here is 2x squared minus 10, 2x squared minus 10, okay? The angle QPM is 8x, and MP is 10. Find the indicated measures. So number 36, it says we need to find the measure of LPQ. LPQ. Okay, so this part of this angle here. So I need to find out what that whole angle is and then divide it by 2. I know that opposite angles are congruent in a rhombus, so let me set the two angles equally to each other. So right away we should see that this is a quadratic because there's an exponent here. So we want to move this 8x over to the other side, and we'll get 2x squared minus 8x minus 10 equals 0. I'm going to factor out a 2 just so I have smaller numbers to work with, and I'm left with x squared minus 4x minus 5. I factor, and I get a times c is negative 5, b is negative 4. I want to find the factors of negative 5 that add up to negative 4. And that is negative 5 and positive 1. Negative 5, positive 1. I get x minus 5 times x plus 1. Set them both equal to 0. I get x equals 5, x equals negative 1. I don't use the negative 1 because I don't want the distance to be negative on either of the angles, or don't want the measure to be negative, so I use x equals 5. Now I want to find the measure of LPQ, so I'm going to substitute x equals 5 into the measure of angle QPM, which is 8x, so I substitute and I get 40. But then I want to find half of that angle, 8x. I want to find this half. So I divide it by 2 and I get 20 degrees. So 20 degrees. Number 37 is super easy. QL, let me erase some of this figure. It's getting really messy. QL is this side here. We know that all sides on a rhombus are congruent. So if this one is 10, this one has also got to be 10. Easy. Now 38, it says angle LQP. So angle LQP. So this big angle right here. We need to find the measure of it. Well, we know that this angle here was 40. Opposite angles are congruent, so this angle has to be 40. And I know that all of the angles in a parallelogram add up to what? 360 degrees. So I do 40 plus 40 plus, this one here is x, opposite angles are congruent, this one is x, 2x equals 360. I get 80 here plus 2x equals 360 minus 80 minus 80. I get 280 here divided by 2. X equals 140. I put that over here. And now we do number 39. LQM. Let me erase this. LQM. LQM. So this angle here. Well, let's see. If this angle here was 40, we found this angle to be 140. And we know that diagonals bisect the vertices. We can just do 140 divided by 2 and get 70 degrees. Let's try one more. So it says use rhombus XYZW with the measure of angle WYZ as 53 degrees. VW, so the diagonal VW here is 3. Oh, that doesn't look like a 3. Is 3. XV, so this side here, XV, this diagonal, is 2A minus 2. Make sure you put it on the line. Don't put it like randomly in some other place and then get confused. And then ZV, this part here, ZV, is 5A plus 1 over 4. 5A plus 1 over 4. So the property I'm going to use is that for A is that diagonals bisect each other. So I know that this piece here is congruent to this piece because diagonals bisect each other. Therefore, I set those two pieces equal to each other and I solve for A. Cross multiply, I get 5A plus 1 equals 8A minus 8. I move this 1 over here. I get 8A minus 9 equals 5A minus 8A minus 8A. I get negative 3A equals negative A divided by negative 1. A equals 3. Oops. Oh, this should be a negative 3. Okay. I get A equals 3. So now I substitute. Oh, I'm doing part C on accident. Okay, so this is part C. So I substitute A back into this part here and this part here and then add it together. So I have 2A minus 2 plus 5A plus 1 over 4. And now I substitute in for A. I do 2 times 3 minus 2 plus 5 times 3 plus 1 over 4. I get 15 plus 1 gives me 16, divided by 4 gives me 4, plus 2 times 3 gives me 6, minus 2 gives me 4. I get 8 here. And this one is 8. Great. So let's do letter A. It says find the measure of YZV. YZV. Okay. So remember, if we have a tricky figure, we just split off the part that we're trying to solve. So 3A plus 1, remember we substituted in over here and we got 4. Oops. We got 4 for this length here. This is a right angle. This is 53 degrees. So I'm trying to find this angle here. Well, I know that this angle here is 53. I know that this is 90. So my unknown x will be the third angle equals 180. I add these two together. I get 143 plus x equals 180 minus 143 minus 143. I get x equals 37 degrees. So the property I used here is that diagonals are perpendicular because that allowed me to use the right triangles to solve the rest of the angles in the triangle. So this one here. So part B, it says find the measure of x, y, w. X, y, w. So this angle here. Well, I know that the diagonals bisect the vertices. So if this here is 53, this here also has to be 53. This one is easy peasy. And now I go to part D. It says find XW. XW is this side here. Let's split off a right triangle here This is 90. We know that this side is 3. They tell us that, let's see, this one is 4. So I have 3, 4, and then I can use the Pythagorean theorem because I have 2 sides and a right angle here. So now I do a squared plus b squared equals c squared. I plug in my values. What is c? We don't know. So c is my unknown. This one here is a. This one here is b. I get 9 plus 16 equals c squared. I get 25 equals c squared. Square root, c equals 5. And that's